In this experiment, what we're going to do is we're going to build a dense network. So we're going to increase the density of the hidden layers in your neural network. All right. So the default values are 64 and 64 on both the layers. So this is how the default network looks like. And we just ran the shallow network with a couple of variations. Now we're gonna increase the density. So I want to have 512 neurons on the first layer, 128 in the second layer, and I'm not going to touch the third, as this is how it's supposed to be. And let's compile this. So as you can see, the number of parameters have significantly increased. So you have now 72,000 parameters. So as you can notice that as you increase the density, this has significant impact on the number of parameters. Okay, let's go ahead and train this model now. Since you have increased the number of neurons, this is taking a bit longer, as you can notice. All right, it's complete. Let's plot it now. So there you go, a lot of ups and downs, but as you can see, the mean absolute error is now below 1, which is a good thing. Let's go and print the actual numbers. So here you have a loss of 3.7, so 1200, and 13.76. This is almost the same as your average run. So let's run this again. So I'm going to run this again. I'm not going to change anything. I'm just going to run the training again. So as we know that the weights are randomly initialized, the results could be different on every run. It's complete now. So let's print the loss here. So as you can see, this is the previous loss, and now the loss is still somewhere around 3.7, but it's a bit less than that. All right. So this is the actual idea. Now to actually compare this, let's go and change it back to 64 and 64. Now let's compile and run this. While it is running, keep in mind that we used a heavy layer and these were the numbers. Now we are reducing the number of neurons significantly. It's significantly shallow in terms of parameters as well. In the previous experiment, we have 72,000 parameters. Now we only have 5,000 parameters. So obviously, by increasing the number of parameters, you increase the bandwidth or the capability of your network to learn more features. So let's go ahead and run this now. So it's already complete. So as you can see, this also is performing somewhat in a similar fashion. So let's go and print the error here. As you can see now, this is 3.59, which is good. Almost this is performing better than that. So let's run this again. So as you can see, this time the numbers are much smaller, and as you can see, the error is even below $1,000, and here it is actually a bit higher, and it's at about 2,700. So there is a possibility of overfitting, which you have to keep in mind, and there is a possibility of underfitting also, which you have to keep in mind. So as you can see, that just by changing the density of the network, it doesn't mean you might always get better numbers or good numbers. You have to find the sweet spot for every network. It's different, depends on various numerous factors.